So very good afternoon, students. So in this session, we are going to discuss about the data frame functions. So what are the different functions we have in the data frame? The title for this is your data frame. You can say high order function, right? This is the topic for today we are going to discuss. Now, when we say functions regarding the data frame, we are actually talking about the actions and transformation itself. So now, especially in this data frame, because the data frame is related to the relational databases, relational structured data, so we call as the structured operations. So I'm just mentioning as a structure operation over this, right? So now, what is a structure operation? This structure operations actually comprise of action and transformation, but unlike your RDDs, these structure operations are designed for or designed to relational relational aspects, right? So you can say that these are the mirror, the kind of expression which is equivalent to the expression which you have done in SQL. That means whatever things you can do in SQL, so something like that you can also do in these kind of structure operation. And I hope you in SQL operation you have done this thing like projection. So we can also do over here, or you can say filtering, or you can say transformation or transforming, or even joining also we have done in the same thing we can do in the structure operation. When I say this structure operation, it is something similar to the RDDs. What kind of RDDs things? Like in RDD we have a transformation and we have actions. So that is something similar to the things which we have discussed in RDDs. Now in the structure operation we can say anything which is like structured transaction. So when I say structured transaction, now I'm using the word structure in transformation. So this transformation is again lazy evaluated. But on the other hand, we have a structured action. This is eagerly evaluated. Eagerly evaluated. Right? Now, in the structure operation, in the lab, we have seen few of the structure operations that we are going to do each and every, most of the operations and transformation or actions we are going to cover in this session. Now, while performing the different operations in the Spark data frame, we have used the word called DSL. That means this structure operation can also be described as a DSL. So when I say DSL, I mean to say it as a domain specific language. And this word you're going to see in the whole big data operations. So whatever the technology you're going to use, they have their own domain specific language, and this domain specific language for the distributed data manipulation, right? So now the question is what is the DSL? Okay, so just I'm giving a very high level idea that DSL can be called as like a computer, you can say computer language which is specified for particular application domain. Okay, and application domain. And in our case this, hence the application domain, or you can say here in this part, I'll use this change word. I can say that in this application, in this approach, whatever we are doing is, so here we can say that application domain is your distributed data manipulation. So we need to do all kind of these things in this approach. Now your data frame is actually immutable. The data frame is immutable, just like an RDD. So similarly, if you apply some transformation over this, so what will happen? It will return the new data frame because this is immutable. Okay. So now let's see what are the different ways of referring the column. We have used the column field many ways, but I'll just show you what are the different ways through which we can define the column. We can use the column. We can use the column in the double bracket. column and we can put a column name over here, or we can also use col and then we can put column name over here, or either we can also use full column and the column name over here, or you can also use $sign and then double quote and then you can put column name over here. This is different ways. Sorry, not, it will not come, but there are different ways you can put on. Even you can also use single tick. This is a single tick and then you can put a column name. So these are the different ways through which we can define the column name. Okay. Now, one of the first transformation we are going to discuss about is your select. So select and the columns. This is the first one. Right. Now, this select is basically used, you can say used to perform projection. And this projection is, that means out of the n number of columns you want to fetch or you want to display 5 columns or 2 columns. So this is used for the just to perform the projection. Here what we can do, we can select all, or we can select subset of columns, right? And what happened during the selection, each column can be transformed if it is needed. Each column can be transformed via your column expression, right? Now here we have 2 ways of doing a transformation. First one is, let's say first one is you just take your column as a string, and second one is you can take the column as the column class. So these are 2 different ways you can mention these 2 things over here, right? Now we can define this column. Like if we take an example of this column, it is quite simple. Let's say we have example I'm putting over here after this part. So let's say example, we have a data frame. Okay, so now data frame dot select, and then we have a column 1, and then we have a column n or column 2, whatever, and then I can call show, and then I'm saying show element 5. Okay, but instead of that, you can also use, or it can use column expression also over here, right? So this is about the select, and we have seen this in the class, in the different demo section also in the lab. The second one is your select expression, and then I need to give some expression over here. So this is your second, this is your first, this is your second. Now this select expression is just, you can say, a variant of the select transformation. So this is another variant of the select transformation, and you can say this is different in terms of, like, because it accepts the one or more SQL expression rather than column. Instead of that, it uses the SQL expression, right? And these 2, select as well as select expression, both can perform the same operation, same projection or same projection task. But the later one, which is called an select expression, is little powerful and flexible also. So just you can say it's a flexible construct. Why? Because express the things in a natural way. So whatever we can speak, select star from this. So that means you are able to provide a SQL expression, which is something like your English syntax kind of stuff. So this is more powerful and flexible. So how we can define over this? We can, like, let's say data frame is df, and we can call select, and E is capital over here, expr, and then we can say that, let's say count, and we are counting the element from the data frame. Then we are counting actually, let's say movie title. So we are counting the movie title or movie title. Okay, so this is your code for writing this. So this is about the select and the select expression. Now let's talk about the filter. Filter is very quite common. So filter, and I have to give a condition, or we can have a where clause, and here also we need to give a condition. Now this filter is actually used to filter out the rows. Which rows? That we don't want to, or they don't meet the given condition. Or we can also think in another way that this filter will, what it will do, it will return rows that meets condition. Okay, so these are the two different perspectives. The things are same. Either you are filtering out this which don't meet the condition, given condition, which we are going to put, or you can say it will return the rows that actually meeting the condition. So here your filter and your where, both are having the same behavior, right? But this particularly where clause is, you can say, bit more relational than filter. Okay, so now how we can give an example? Let's say we have a data frame df, and then I am going to use filter, and then I'm saying, okay, this is an year, this is a tick, okay, this is a year is greater than 2000. Or we can also say df dot where, and I'm saying where year is greater than 2000, this is a tick. Okay, so this is the way of defining the filter. This is quite simple and so forth, right? Next we have distinct and drop duplicates. D is capital over here, drop duplicates. Now these two things, these two transformations are identical. So these two are identical, having the identical behavior, right? But you can say that the drop duplicates actually allow to control that which column should be used. Okay, so in case if you want to drop the duplicate that contains some logic and you want to deduplicate that, so that means it should be used in your deduplication logic. Okay, if none is defined, let's say, then it will do for all the columns. Right? It will do for all the columns. So distinct and duplicate or something like that. So here, how we can define these two is, let's say we have one movie data frame, so you can select movie.select. So here I'm just giving an idea. It's not exactly, it's just a code snippet. Okay, so just we have a movie select, and in this movie, let's say we have a movie title. So we are doing movies underscore title. So we are selecting, and after selecting this movie title, we are saying, let's say distinct. So here distinct, I will do the distinct, and then after that we have a select expression over here, and this select expression is actually counting the movie title. Okay, and then I'm giving a name to that as a movie, right? Movie, and then I can say show. So this is a part of the lab. Similarly, if I have something, so what I can do, I can use like movies dot drop duplicates, and then I can write movie title, and then I can say select expression, and then the same thing what we have typed over here, count movie title as movie, and then I'm calling the show function. So now here we have a distinct over here and the drop duplicate. So now in these two things, just to distinguish, I'm using a different color for each functions. So now if I say in terms of performance, so in terms of performance, there is no difference. Why? Because Spark will transform them into your same logical plan. That is why the performance is same. There is no as such performance difference is there into that. Okay, so this was about the distinct and duplicate. So now next one is about the sort, and I'm giving the columns, or we have a order by. Okay, this is the next. Now the sort and order by are having the same semantic. Semantic means meaning, having the same semantic, but the order by is more, you can say, relational. And for ordering, we have a default value is like sorting. In the number default is your ascending, and you can also change it to descending, and it is a very simple way of defining that. Okay, so let's say we have one data frame called movies title, and we are sorting over here, and we are sorting based on some title length, and then I can call show of 5 top 5 movies I'm going to see in a result, right? Similarly, we have movie title dot order by, and then I can say that title underscore length dot descending. So here I need to add, and then I can call show. So this is the line where it is changing from ascending to descending. Okay. Now next is your limit. Now limit is quite simple. Thus this limit actually returns the new data frame. So it returns new data frame. Okay, and it will, I'm just writing returns new data frame, and by taking n rows, n is coming from here, and basically this is used with sortings. So used with, basically it is used with sortings. So why sorting? In the sorting, just to figure out top n element, or you can also put like bottom element, or bottom, or based on your bottom n elements based on your sorting. So if it is ascending or descending order of the sorting. Now next one is your union. So union is like you have to mention some other data frame over here. So union is basically applied when we need to add more rows in the existing data frame. That means we need more rows to add in existing data frame, right? Now we can also use this union just for combining the rows from two data frames. But the required field over in this union is both the data frames have same schema, right? Have same schema. So what is the meaning of same schema? I mean to say that the column names and their order must exactly match, right? Now we can also define like this, df1 dot, let's say, union of df2, then I can say show this. So now next one is very simple with column, and very powerful thing is there. So let me add with the with column, and we have to mention the column name and column name and something like that. That means this with column is actually used to add the new column. So it's used to add the new column in the data frame. So we can use with column, and it required two input parameters, right? So like parameter like input, parameter like a column name and the value in the form of, this is 1 and this is 2, in the form of column expression. Now the with column, whatever things you can do with the with column, you can also do with the select, can also do with select expression. Now the next one is your drop. The drop is a column 1, let's say column 2. The drop is very simple. The drop actually drop the specific column or columns from your data frame, and you can specify one or more column. This is quite simple. Now another very simple and interesting thing is your describe and the column name. Now this describes, gives the basic statistics of the data. Here what you can do, you can compute for your string. Okay, so you can compute for this describe, you can only compute for your you can say string part or any numeric column available in the data frame. So you can compute this statistics for the these two columns, strings and numeric. And what kind of statistic? That is the transformation. So what kind of transformation you can do? Like transformation like count, mean, standard deviation, or minimum or maximum. So these are the things which are there as a part of transformation in the describe. When you call the describe, you're going to see this in very detail. So this is about the transformation. So now let's see what are the different actions. So now let's see what are the different structured actions are there. Structured actions. So one of the actions are very simple because we have seen many of the things. One is a show. This show will display the number of row in the tabular format. So that means number of rows in tabular format. Okay. Now you can say just like in Java we have overloaded method. So we have show and then number of num rows. So what it will do, if the number of row is not specified, then the default value it will show you the top 20 rows. And if the number of row is specified, it will show you that much of column, number of rows, top n number of rows. It is going to show you. Sorry. Another variant of show is you can put a truncate also. And when I say truncate, that means in this truncate you have the options. This truncate option actually controls whether the truncate the string column if its character is more than the 20 character. Okay. So if I'm just writing string column is longer than the 20 character, it will truncate. And the fourth, you can mix two things like show num rows and truncate. So you can add both the things together. So this is about the show. Now another one very common, you can say actions are head, right? So what head do? Head actually will return the first row, and if n is not specified. Okay, if n is specified, then it will give the n number of rows. So that it is something to your limit also. So but right. So now it will return the first row, and you can also put head of n. Then what it will do? It will return the n. You can say first n rows, or you can say this first is actually alias to like your head, because you can give the if you give a head or first, then it will give you the same thing. Okay, even take n is alias of the first n. So you can say this logic that take of n is something equivalent to the first of n. You can say alias of the first of n. This is important to remember. Okay. So now for that we have another function called actions called first. So it will give you the same n rows for that, right? This head will give you first row, head n will give you the first n rows, right? So something similar to like that. Similarly, we have a take of n. It will also work in the same way. So these four will work exactly something like same. Now other actions we have is like other action we have a take as list. Here you can put n. So what it will do? It will return the first n row as a Java list. So let first n rows as Java list. But you have to be careful not to take too many rows into that. Otherwise, what it will do? It may cause out of memory error on the application driver process. Okay. So just don't go beyond some certain limit, or you can say don't take too long. Otherwise, it will become out of memory error. After that, we have collect, which is we have seen many times. Collect. So collect will return all the rows as an array or a Java list. That means it will also do the same thing. But it will take all the rows as an array or Java list. And this function is not recommended when you have a large data set, because this runs on the driver side and all the result have to go to the driver. Similarly, like a collect, you can also have the collect as list, right? So this will also something as a like thing. It will also take the same action, and it will take as an action as a list action. Last but not the least, we have a count, and it will return the number of rows in a data frame. Okay, so this is all about the action and transformation, or you can say all the structured operation. We have discussed most of the structured operations in this lecture. Thank you very much for that.